So today we are going to talk about cube and cube roots. So in your previous classes, in class 6 to class 7, you've already learned about the solid figure of a cube. Let's have a look. So we know about a solid cube which has unit length A, and this is going to be A in all the dimensions. So we know the volume of the cube as A cube, and therefore in understanding of these, or we can write this as, A into A into A. So in the same way, cube of a number is the product of the number by itself 3 times. So for example, if we take the cube of 5, that would be 5 into 5 into 5. Similarly for 7 cube, it would be 7 into 7 into 7. Let's look at some of the perfect cubes or cube numbers that we have. So for natural numbers 1 to 10, the cube roots would be 1, 8, 27, 64, 125, 216, 343, 512, 729, and 1000. I'll just also write the rational numbers below it. So these are the natural numbers, which are the cubes of the natural numbers from 1 to 10. So if we have to express this in a very formal definition, then we will say natural number m can be expressed as n cube, where n is also a natural number, then m is the cube number or a perfect cube. So this is the formal definition. So then we also understand that not every natural number is a perfect cube, and there are a lot of numbers in between certain perfect cubes that are not perfect cube. So how do we understand if a number is a perfect cube or not? How do we find that out? So let us take an example, 216. We have already known from the table that it is a perfect cube of 6. But how do we prove that? So in order to do that, there is a certain method in prime factorization. So we'll do the prime factorization, where 216 is again 108. Then again by 2 we get 54. Then again by 2 we get 27. Then again by 3 we get 9. 3 we get 3. And 3 we get 1 again. So that's the prime factorization, and let's express this in terms of these prime factors. So that is 2 into 2 into 2 into 3 into 3 into 3. So let's now make triplets of these. So there's one triplet of 2 and there's another triplet of 3. So we'll take one out of each triplet. So the cube root of 216 would be 1 out of the triplet 2 and 1 out of the triplet 3. And that comes out to be 6. And that's how we prove whether a number is a perfect cube or not. Similarly, let's take another example of 192 and see whether it is a perfect cube or not. So we'll again do prime factorization, and let's see what comes out of it. 196, we get 2, 96, 48, 2 again, 24, 2 again, 12, 2 again, we get 6, 2 again, we get 3, 3, and then we get finally 1. So let's express this in terms of prime factors. 2 into 2 into 2 into 2 into 2 into 2 into 3. So let's create the triplets. There's first triplet of 2, second triplet of 2, and then this is an unpaired, or there's no triplet for 3. So therefore, as we cannot express 192 in terms of triplets of 3, therefore this is not a perfect cube. So let's now talk about some other type of questions that can come for your exam. So in this question, we need to first identify whether the number 2376 is a perfect cube, And if not, then by what smallest number should it be divided so that the number becomes a perfect cube? So for this, we again need to find the prime factorization of 2, 3, 7, 6 first. So we'll do that. We have 2, we get 1188, 2 again, we get 594, we have 2 again, we have 297, we go 3 again, 99, 3, 3, 3, 3 again, 11, 11, and then 1. So in terms of prime factors, let's express this as 2 into 2 into 2 into 3 into 3 into 3 into 3 into 11. And now let's make the triplets. So we get the triplet of 2 and then a triplet of 3. And now we see that 11 is again unpaired. So because this question asks what should be divided by the number, we will take this number 11 and divide it by 2, 3, 7, 6 to get the perfect quotient that is being asked in the question. So let's see what comes out. So when we divide it by 11, we get 2 into 2 into 2 into 3 into 3 into 3, and the 11 is gone. So we get this, and the perfect cube that comes out to be, so this number becomes 216, and the perfect cube of 216 6. That's how we get here. So now we are going to talk about some interesting properties that we come across these perfect cube or cube numbers. So let me just create a quick table for everyone to have in order to understand or know what the cube numbers are and what is the cube root of all of these numbers. So here we have a table of all the natural numbers from 1 to 20 and the cubes of these. And as we have this table, we will now be able to visualize these properties a lot better. So let's move on to property number 1. So the first property is the cubes of odd numbers are odd and cubes of even numbers are even. Let's observe the table above. So we can see that for 1 it is 1, for 15 it is 3375, for 7 it is 343. So all odd natural numbers will have odd cubes. And let's look at some even ones. So for 4 it's 64, for 16 it's 4096, for 20 it's 8000, and so on. So therefore, we can say that the cubes of odd numbers are always going to be odd and cubes of even numbers are always going to be even. Moving on to property number 2. So let's observe the table above here again, and let's look at the unit place of both the natural number and the cube. So we have a couple of observations. So if a number has 1, 4, 5, 6 or 9 in its units place, the cube will be same as the digit 1, 4, 5, 6 or 9. So let's write that down in our table. So if it is 1, 4, 5, 6 or 9, then it would be same 1, 4, 5, 6 or 9. If we go back again, we see for every one of the two, for a true in the unit place, you will have 8 in the cube unit place. For k, 8 in the natural number unit place, you will have 2 in the cube unit place. We'll write that. For 2, we have 8, and for 8, we have 2. And this goes on to again 3, we have 7, and for 7, we have 3. So that these are interchangeable. So 8 and 2 are interchangeable and 3 and 7 are interchangeable. So let's write that down. 3 and 7 and 7 and 3. So it's easier to understand. And finally we have 0. So for 0 we'll always have 0 its unit place. And that was same in squares as well. So that's that. So let's move on to our third property, which says that cubes of a negative integer is always negative. So let's have a look at that. So let's take an example of -2 and take the cube out of it. So we'll have -2 into -2 into -2. So what this gives us is -2 into -2 becomes +4 as the two minuses cancel out. But if we multiply +4 into -2 again, we'll get another negative number, which is -8. So that's how it comes out. Even if we take the cube of -7, we have -7 into -7 into -7. And this again gives us, in the same fashion, -343. And that's all for the properties of the different kinds of cubes and cube roots. So let's move on to a more interesting topic of cube roots. And what does a cube root mean? So let us again consider, let's take this cube of side length A, and it has A in every dimension as a length, breadth and height of it. So again, volume of the cube is A cube. So what would be the length? So length would be something that is of a cube root of sorts of the volume, which will then gives us A back again. So let's take an example of, say, the volume is 729 meter cube, and if we need to find the side A of which this exists as a volume, then we need to find an operation that brings out all these values together, and that is the cube root, and that comes out to be 9. So in formal terms, we can define it as cube root of a number n is the number which, when multiplied by itself 3 times, gives n as the product. So now comes the question, how do we find a cube root of a particular number? And this can be done through multiple methods, but we will just learn about the factorization method for now, or say the prime factorization method. So let's start with our first example, where we'll just find the cube root using this method, and I'll explain it to you step by step. So let's take the number 1728. So in order to do the cube root, we'll first take the prime factorization as we do in the square roots as well. So 1728, we get 2, then we have 864, then we have 2 again, we get 432, we get 2 again, 216, we get 2 again, 108, we get 2 again, 54, we get 2 again, 27, take 3, 9, 3, 3, 3, and 1 again. And that's how our prime factorization is. And then we will again break our number down into the prime factors. So we have 2 into 2 into 2 into 2. And then we have another pair, another triplet. And then we have a triplet of 3. Now we are going to create these triplets and take one number each out of the triplet. So the cube root, which is denoted by this notation, would be 2 into 2 into 3. And this comes out to be 12. So this was the simple first kind of a question. Now let's look at the cube root of a negative number. So let's say we have a cube minus a cube. That would be minus a into minus a into minus a. Let's use a very quick example. So we'll find the cube root of minus 512. So for doing this, we need to understand that we can take the minus out of the cube. So this would again become minus of under root of the positive 500. Now we'll find the prime factorization of 512, and that comes out to be 256, 2 again, 128, 2 again, 64, 2 again, 32, 2 again, 16, 2 again, 8, 2 again, 4, 2 again. Yeah. And that's our prime factorization. Let's write this down. So 2 into 2 into 2. So we have 3 triplets of 2. And then our cube root of 512 would be 2 into 2 into 2, which comes out to be 8. And for negative 512, we have minus of cube root of 512, which comes out to be minus 8. And that's how we get the cube root of a negative number. So let's look at another interesting thing, which is cube root of a product of integers. So let's say we have two numbers or integers, say a and b, and their cube root would be cube root of a into cube root of b. So let's solve some examples based on this. So let's evaluate the value of cube root of 27 into 64. So this is cube root of 27 into cube root of 64. So from the table that we already know for the cube roots, we know that this is the value of cube root of 27 is 3, and for 64 it's 4. So this comes out to be 3 into 4, and the final value is 12. Similarly, if we have any kind of a rational number a by b, so for finding that cube root, we will then divide the cube root into above and below as we did that in the multiplication part. So that would be cube root of a divided by cube root of b. So let's evaluate cube root of 216 divided by 729. So we can also write this down as cube root of 216 divided by cube root of 729. And we know through prime factorization, this is cube root of 2 cube into 3 cube, and 729 is 3 cube into 3 cube. And this comes out to be 2 into 3 divided by 3 into 3, and we can simplify this as 2 by 3. Now let's look at cube root of a decimal number. It is very similar to how we do it for any rational number. So we'll take an example and go step by step how it is done. Say we need to find the cube root of 0.216. First, we need to convert this decimal into a rational number or a fraction, and that would be cube root of 216. We remove the decimal to get 1000 below in the denominator. And then again, as we did it previously, we'll have cube root of 216 and cube root of 1000. So from our table, we already know that this is the cube root of 6. And from our table, we also know that this is the cube of 10. So we have 6 by 10, and we can simplify this as 3 by 5 or 0.6. So that's our cube root. So let's take a final quick word problem where we can use cubes as a interesting way to create the equation. So here we have a word problem where there are three numbers which are in the ratio of 1:2:3, and their sum is given, the sum of their cubes is given as 7,776. So we need to find the numbers. So let the three numbers be x, 2x, and 3x. And why did we do this? Because it says that the ratio is in terms of 1:2:3. So that's how we take the numbers. And then we know that the cube of these numbers can be summed up to 7,776. So we'll write it as x cube, 2x whole cube, and 3x whole cube is equal to 7776. So x cube plus 8x, we'll open the brackets, 8x cube plus 27x cube is equal to 7776. We'll have 36 when we add them. 36x cube has 7776. Then we have x cube is equal to this division, which gives us 216. And through our table, we know the cube root of 216 is 6. So our first value is x equal to 6. We have 2x equal to 2 into 6, that is 12. And our third value is 3x, that is 3 into 6 is 18. So our numbers are 6, 12, and 18. And this brings us to the end of our chapter on exponents, square roots, and cube roots. If you like our channel, please don't forget to like, share, and subscribe.